Okay, hi guys. So in this video lecture we'll be starting off with our new chapter, which is called General Organic Chemistry, and in this we'll be studying inductive effect, resonance effect, hyperconjugation, electromagnetic effect, steric hindrance of resonance effect, and field effect. So don't get intimidated by all these words. Means we'll be taking off with all these terminologies in few minutes, or maybe in the next video tutorials, but for the time being I'm just writing all the names here. So inductive effect, resonance, hyperconjugation, electromagnetic effect, steric inheritance of resonance effect, and the last one is field effect. So out of these six, the top three are very important for us, and we'll be taking more amount of time studying those. So those are in our scope. So what's an inductive effect? So inductive effect can be of two types, plus I effect and minus I effect. Plus I and minus I. So what is plus I? Plus I means simply electron donating groups, and minus I simply means electron withdrawing. Okay, so let me take some of the examples of compounds which are plus I, or electron donating compounds. Okay, so we have for plus I this substituent is actually plus I, and who is taking the electrons from this compound? It's substituted Cl group. So in this compound, Cl is considered as having minus I effect, and this butyl group is considered having plus I effect. Why? Because as you know, chlorine is more electronegative than carbon atom, so there is a slight shift of electron, delta shift of electron towards chlorine atom, and carbon atom will have slight positive charge. It means that it is the electrons are slightly shifting from carbons to chlorine. They are not exactly shifting, but they have a tendency to shift, right? So for that purpose we can say that this group has a plus I effect and this has a minus I effect. In turn, all these carbon atoms will have plus I effect only, because all these electrons will tend to move towards chlorine atom, right? As this carbon gets more positively charged because of this chlorine atom, delta positive charge is there, so electrons from this carbon atom actually tends to move towards this carbon atom. Similarly we can say for this and for this. So in this way the whole compound actually gets a plus I effect towards the chlorine atom, right? So let me take another example. If we have something like CH3, CH2, CH3, so would we have plus I or minus I effect in this compound? No. Why? Because there is no difference of electronegativity. All the atoms in this compound are same, which are carbon atoms. So there is no difference in electronegativity between among the different atoms among the atoms in this organic compound, right? If we have something like this, now as you can see that this is a double bond between two carbon atoms, and these two carbon atoms are sp2 hybridized, right? And this carbon atom is sp3 hybridized. So for now, if you don't know about the hybridization thing, don't worry, we'll be taking this up in our next set of video lectures. But for now, please just remember that double bonded carbons are sp2 hybridized and triple bonded carbons are sp hybridized. Okay, and we know the fact that electronegativity of sp2 hybridized carbon is greater than electronegativity of sp3 hybridized carbon atoms, right? So just remember this as a fact for now, and using the same we can say that as electronegativity of this two carbon atoms is greater than the electronegativity of this carbon atom, we can say that this will have minus I effect and this will have plus I effect, right? So let's continue with some more examples. We have something like and CH3 group attached. So which carbons or which set of carbon atoms in this compound would be having a minus I effect and which carbon atom would actually be having plus I effect? So if you see from the previous explanation, you would have by now guessed that this ring actually have 3 pi bonds in its carbon atom. So this ring will have minus I effect and this group would have plus I effect. So slight movement of electron would be towards this phenyl ring, and that shift would be coming from CH3 group, which is in turn having a plus I effect. Why? Because these carbons are sp2 hybridized and this carbon is sp3 hybridized, and the electronegativity of sp2 hybridized is greater than electronegativity of sp3 hybridized, where En means electronegativity. Okay, so let us look at some more example. Let's suppose we have something like this benzene ring. Okay, and this benzene ring actually have a nitrile group attached to it. So now in this case, what would be the plus I effect substituent and what would be the minus I effect substituent? So if you look carefully, we can see that so in this case, nitrogen is more electronegative than carbon, plus there is a triple bond between carbon atom and a nitrogen atom. So this carbon atom is actually sp hybridized, and whereas this phenyl ring is sp2 hybridized. So as I said earlier, sp hybridized carbon has more electronegativity than sp2 hybridized carbon atoms, right? So in this case, the phenyl ring would exhibit plus I effect and the cyanide ring would exhibit minus I effect, and the electron shift would be towards cyanide side, nitrile side, I beg your pardon. Okay, so let us look at this example. So we have a cyclohexane ring which has CH3 group substituted on it. So what would be this plus I effect and minus I effect on this carbon atom? Means which carbon atoms in this compound would exhibit plus I or minus I? So yeah, tell me. So if your answer is there can't be any electronegativity difference, so there can't be any plus I or minus I effect in this carbon atom, then you are absolutely right. Because when I say that there is some electron shift, so where does that electron shift comes from? It comes from the electronegativity difference between two atoms, right? So in this case, as all the carbon atoms are sp3 hybridized only, then there is no electronegativity difference, hence there is no plus I or minus I effect in this compound. Remember this is very important example to clear your doubts and concepts, misleading concepts maybe. Okay, so in this case drawing is very simple, that this would be having minus I effect and this group would be having, ethyl group would be having plus I effect. Why? Because electronegativity of carbon atom is less than the electronegativity of fluorine atom. Okay, so let us look into some more examples. We have something like this. So in this case, which carbon atoms would exhibit minus I and which would exhibit plus I? So in this case, plus I would be from this group of carbon atoms, and this would be having minus I effect. Let us discuss some more problem. So after this example we'll take up that problem as well. Let's suppose we have this thing, then again its electronegativity would be more than sp2 hybridized carbons, hence this would be minus I effect and plus I effect. So now I'll just give you the summary of what we have discussed. In fact, with an example I will try to give you an overview of what we have talked till yet. So when you actually see these type of compounds, the general trend of, or the trend of electronegativity would be from carbon atom to chlorine atom, as chlorine atom is having more electronegativity. So as the number of chlorine atoms substituted on carbon atom increases, the minus I effect also increases. Okay, so same can be said for this thing, that as the number of carbon atoms attached to a minus I effect group increases, the plus I effect would also increase. Why? Because there are more number of giving groups, hence the plus I effect also increases. So in the next video lecture I'll be giving you some more examples on comparing the minus I effect of various groups. We'll have some formal definition of inductive effect and some of its properties, and we'll have some more examples. Okay, good luck and goodbye till then.